Thanks. Thanks very much, Annie. I appreciate it. Salil and I would like to welcome you. We actually do welcome you. And I will then, after giving an introduction, will then introduce our speaker. I hope you're all well and your family and friends are well, and everything they've been telling us in the news is just really a joke and not real, but unfortunately it is. In any event, we're thrilled that we could all get together here today virtually with the common purpose of bringing OpenDP to reality. So what is OpenDP? OpenDP has 4 parts. It is open source software that's owned by all, publicly validated, trusted, and trustworthy. I mean, it's great that there's lots of business models for software, but it doesn't make sense to have privacy software that's private. There's no way to actually implement it. So it would be open source. First is software. Second is a community devoted to deciding what validated and trustworthy actually means. It's devoted to working together to tackle the vast array of issues as new data sets are discovered and new use cases are surfaced and new quantities of interest are identified and new statistical methods are developed. And finally, the community is devoted to building the differentially private approaches and the software and the methods necessary to make sure that everybody has both utility and privacy. The third piece of OpenDP is a set of institutions to support the software building and the community. So far, we have Harvard's Privacy Tools Project from SEAS that Salil leads. We have Harvard's Institute for Quantitative Social Science that I get to lead. We have generous support from the Sloan Foundation, which has led the effort, initiated the effort in providing financial support, which we all utterly appreciate. The Microsoft Corporation, which has provided some terrific people and some great use cases, lots of energy, and some other firms are stepping up as well, which is really great. We also have a growing group of smaller research projects and firms that are trying out the software and building applications on it to begin with. And most importantly, as part of the institutions, the third piece of this is we have all of you. So that's 3. The fourth one is a proposed new unified direction for the field. I mean, traditionally scholars pick a particular place to focus on the thin slice from abstract mathematical theory to practical application. But nothing in this area really works unless you're paying attention to the whole range. And theorists can, perhaps for the first time, sometimes interact with the people doing applications, and the application people can talk to the theorists and say, we can't do this, we really need to do this. There's computer science perspectives focusing on privacy and statistical perspectives focusing on utility, and social scientists and many others who need both and need the technology for both. So we're all going to focus on this continuum from theory to practice. With these 4 components, we believe there will be rapid and widespread use of differential privacy in real applications and produce enormous public good over time. So finally, I get to introduce a true visionary. This is John Abowd, who is before you. He is the Edmund Ezra Day Professor Emeritus of Economic Statistics and Data Science at Cornell University. He has been the chief scientist and still is the chief scientist and Associate Director for Research and Methodology at the US Census Bureau. He's been president and fellow of the Society of Labor Economics, fellow of the American Statistical Association, International Statistical Institute, Econometric Society, American Association for the Advancement of Science. I could go on. What's the point, really? Because several hundred years from now, no one's going to remember any of that. But what they will remember is that John Abowd is the person who changed everything. Not only for how census data is being shared and will be shared, but for the many other organizations who will undoubtedly follow along to share their data. The impact of his decision to produce differential privacy and his political skill in making it happen will also completely change the way we even teach statistical analysis, because the noise we add to the data is measurement error. And that means you basically can't use any of the statistical methods you learned in school. And so instead of cursing us for the previous methods we would teach in school, now they will curse John for the new methods. So I thank you, John. But most importantly, as his decision and the Census Bureau's implementation of it and the success of this ripples across the world and other organizations adopt these approaches, society will wind up with way more public good from way more data sourced from way more people, projects, countries, and firms. And I think the new world that we're getting to is really going to be terrific. So I look forward to the many new directions John is about to tell us about.
Thank you, Gary, for that extremely flattering introduction. I hope that my talk lives up to it. And welcome everyone. Before I start my slides, it's great to see so many familiar faces, and it's great to have this opportunity to talk to you. I would like to say that I was going to be joining you for the rest of the week, but this meeting conflicts with the Census Scientific Advisory Committee meetings, and so I'm double booked, and my first allegiance has to be to those Scientific Advisory Committee meetings. So this is the only time I'll be with you, but I will enjoy it. I hope you enjoy it too. So I believe I've shared my slides. The relevant indicators suggest that that's true. I'll look for Salil or Gary, who I can see, for a quick nod, and I assume you can hear me because you nodded after I gave you the cue. Okay, so thanks again for this invitation. And I really do want to rise to the question that Salil and Gary put to me, which is how can the OpenDP community benefit from and contribute to the things that the 2020 census has begun. So without any further ado, let me get started. There we go. Okay. Only one way of advancing the slides works, but I found it. So first of all, I want to acknowledge a very large team of computer scientists, statisticians, information specialists, software engineers, and managers, well over 200, who contributed materially to the implementation of the new disclosure avoidance system for the 2020 census. And this talk reflects their work. And I couldn't bring myself to single out a few for special recognition, but we are publishing papers over the course of the next several weeks with explicit author attributions, and so you'll be able to see who contributed large amounts to the source code database, which will be released, and the technical papers that explain how it works. That'll answer a lot of the questions that you doubtless have as well, and so I'm not going to even try to answer most of those today. So where are we now? On August 21st of this year, the Census Bureau released, this is the formal name of the product, so I try to get everyone to use it, the 2020 Census Redistricting Data Summary File, called for by Public Law 94-171, often referred to as PL 94-171, or amongst the cognoscenti as just PL, but I point out when somebody uses that acronym that there are many public laws, and 94-171 uniquely identifies the one that obligated the Census Bureau to assist in redistricting by publishing these summaries from the 2020 census and earlier decennials. At that time, most state redistricting commissions immediately loaded these data into the software they used to redraw congressional and other voting districts. So they started to use them on August 12th. The Department of Justice Civil Rights Division, shortly after our release, announced that it would use these data to enforce the 1975 Voting Rights Act, just as it did with the 1990, 2000, and 2010 census versions. The state of Alabama and 15 other states voluntarily dismissed their lawsuit challenging the use of differential privacy as the confidentiality protection framework for the 2020 census shortly after the data release. So what does this mean for OpenDP and the differential privacy community as a whole? These are certainly significant milestones in the adoption of modern privacy protection within government agencies. I think Gary more than alluded to that in his introduction, and I think it's appropriate to acknowledge that. But just as it took many decades for sample-based statistical methods to fully supplant enumeration as the basic technique of government agencies and their statistical policies, it's likely to take several decades for formal privacy methods to supplant traditional confidentiality protection systems. That's not a prediction. That's a forecast based on historical data. It has the usual increases like the square of the distance from the forecasting point as you go forward. But acknowledging it as a forecast, I still think it's a reasonable statement. Communities like OpenDP do have a very important role to play, and they can accelerate the adoption for these formal privacy frameworks. And I'm going to try to suggest some ways that that can happen in today's talk. And I'm also going to try to save plenty of room for questions, plenty of time for questions. So first of all, what's the agenda? I'm going to talk about 4 specific points where I think the DP community as a whole, but certainly the OpenDP community can be a big help. The first is in educating data users and data providers on the growing risks to confidentiality protection. A lot of what we understand about those growing risks has not been effectively disseminated. So I'm going to make some suggestions in a few minutes. Secondly, we need to explain privacy loss accounting and especially worst case analysis. Those are fundamental innovations, and they don't seem like such big innovations, I think, to the computer scientists, but they're huge innovations in the applications community, and they need to be treated that way in the educational and supporting documentation. We need implementing tools for privacy loss accounting with explicit accuracy objectives, and I'll have some examples there. And finally, I want to urge you to focus on big data applications, but not exclusively on artificial intelligence, which is the big data application that I think has gotten the lion's share of the attention, although that probably isn't a fair assessment of OpenDP, but it certainly is a fair assessment of the flow of new articles on mechanisms for implementing DP. So on the growing risk to confidentiality protection, we've learned from our experience that the adoption and acceptance of differential privacy is just easier if people understand the growing threat and the need for change. It's very hard to convince people who think everything is fine the way it is without a well-documented case for the growing threat and the relationship of historical or traditional methods to that threat. So the traditional methods, I've said this many times, and my statements have been quoted many times. The traditional methods were broken long before there were viable formal privacy methods to replace them. That they are broken does not mean that they fail every time. It doesn't even mean that they usually fail. It means that the precise way in which they can be defeated is known. It's been known for more than a decade and a half now. Techniques to fix that only became viable basically in the middle of the last decade, in my view. And that was just in time for the 2020 census, and they're still not viable for other things that the Census Bureau does, and we're going to talk about that in a second. So while most people inside the formal privacy or DP community think of the mathematical framework that differential privacy offers for confidentiality protection as its principal intellectual contribution, and then they cite correctly the properties that the fundamental way of doing this differential privacy brings to the table, in particular worst case protection, composition, and other properties. It is really providing an accounting framework for privacy loss that allows global accounting that is, in my view, the most important contribution from the scientific DP literature. And it's the one that practitioners need to learn because it represents the most important replacement of the way that we thought about these problems in using traditional methods. Privacy loss accounting has replaced ad hoc defenses as the standard design for confidentiality protection systems. Ad hoc defenses mean for this specified attack, we propose this procedure, which may or may not have some formal privacy protection properties. The classical system of complementary and primary cell or item suppression has some formal privacy properties, but it protects against a very specific database reconstruction attack and not against more general ones. And its application to cumulative privacy loss protection is still an unsolved problem. So privacy loss accounting really is important. And I have previously, and I will continue to use the analogy to double entry bookkeeping and accounting standards because I think it's instructive. Double entry bookkeeping enabled principled auditing of financial statements, and therefore it enabled generally accepted accounting practices or financial accounting standards to become the common practice. It improved the communication between the buyers and sellers in capital markets. And that innovation is extremely hard to quantify in its contribution to world GDP. But privacy loss accounting is on a comparable scale. It enables proper implementation and auditing of systems that the data steward represents to those who actually own the data. In the case of the Census Bureau, it's the American public, actually implement the statutory protections of their confidentiality that we are required to implement. So its partner is worst case analysis. Worst case analysis is an extremely familiar argument form for cryptographers and for the computer scientists who entered the DP community from the cryptography tradition. But it's really extremely poorly understood in the rest of the scientific world, in my opinion. And the way that it relies on the privacy loss random variable should become a standard component of information science and statistics classes, just the way sampling theory and the derivation of the principal results in hypothesis testing are standard parts of that curriculum. The probability law that governs the privacy loss random variable is based on a statistic that will be familiar to students of information science and statistics from their other knowledge. It's based on the likelihood ratio statistic for a particular point null, point alternative hypothesis, which I coined this term, but I'm sure it's got other names in the rest of the literature, the confidentiality violation hypothesis. A particular statistical hypothesis. I didn't coin the hypothesis. I just want to call it the confidentiality violation hypothesis so that it's clear what we're talking about. It has the form, the statistical output omega from a database that included entity I is the point, versus the statistical output came from a database that excluded entity I. Now I stated here in the original form, we actually use the form, the statistical output omega came from a database where entity I's data have been replaced by an arbitrary record, versus the hypothesis, the statistical input came from a database that, the statistical output omega came from a database that included entity I is the point null and the point alternative is the alternative hypothesis. The statistical output omega came from a database that replaced entity I with an arbitrary record. So one is the unbounded definition and the other is the bounded definition. It's easier to discuss the unbounded definition, but everything I'm going to say applies to either. That's the confidentiality violation null hypothesis, and it has a properly formulated test statistic, which is a log likelihood ratio. And the probability distribution of the privacy loss random variable is entirely determined by that sufficient statistic. So we can understand it, and we can use it to explain how worst case analysis works in terms that statisticians understand. And I'm not the first one to recognize that by any means. Wasserman and Zhao in their 2010 JASA article basically laid it out with the same reasoning. But what's not well understood is the difference between the confidentiality breach hypothesis and the scientific inference hypothesis. So in the same setting, a scientific inference looks like individual I is a member of group G versus individual I is not a member of group G, where group G is a subset of the population in the database. And you can modify it to accommodate multiple categories and other classification problems and other statistics from the confidential database, but it basically has a form like that. And there's a proper likelihood ratio that embodies the data evidence for that scientific hypothesis. And that likelihood ratio is only coincident with the confidentiality breach likelihood ratio statistic when the size of group G is 1. Otherwise, as the size of group G increases, you can draw valent scientific inferences, meaning you can use the information in the likelihood ratio statistic to inform the hypothesis, even in the presence of controlled privacy loss. Your ability to do so clearly depends on how much data information you have about group G, but that isn't really different from other inference problems that we worry about. And so the scientific inference problem has to be cleanly distinguished from the confidentiality breach inference in the teaching of the statistics associated with both inferences and scientific inferences and confidentiality breach inferences. And there, I think the OpenDP community can perform a huge service by developing those teaching and scientific materials and you have the firepower to do that. And many of you have already begun to contribute in important ways to that literature. So I'm not saying this is a virgin field here. It's just where I think the community ought to focus some additional attention. And I'll just show you one example. I have to teach this. This is the privacy loss accounting for the 2020 Census Redistricting Data Summary file, okay? It was done under the Zero Concentrated Differential Privacy Framework, and therefore there are a continuum of epsilon delta values that are consistent with the global privacy loss budget of 2.63 measured in rho. And rho is the right statistic to use here because you can do the privacy loss allocations additively in rho, and then you can take advantage of subadditivity in the composition to generate the corresponding epsilons and deltas. You shouldn't be adding them together. And so we have chosen to present this to the public in the form of the epsilon associated with a failure rate of 10 to the minus 10. So that's the yellow highlighted, 17.44. Whether that's a large or a small epsilon is not something I want to discuss today. What's important is the full transparency. You know exactly what that is. And in a link that I meant to embed in that table, you can get the table showing its full allocation to every query that was done to generate the redistricting data. All 16.6 billion differentially private queries that went into forming the 1.5 billion linearly independent statistics in that data release. That's what I have to teach, or rather what the Census Bureau's communication specialists have to teach, how to interpret that. I don't want to dwell on it now. I'm basically asking for your help in constructing materials that can make charts like this or a graph of this more transparent and easy to explain, or easier to explain. All right. On top of that, We need robust tools for implementing privacy loss accounting. What does a robust tool look like? Well, it looks like real-world explanations of the risk associated with moving that privacy loss budget around across different queries. In the technical paper on the semantics of the 2020 Census Disclosure Avoidance System that we will release in a few weeks, we propose one way of doing this, but I'm sure there are many more ways, cleverer ways that the DP community can work out. And those need to be explained for policymakers and non-technical users as well as for technical users. And there doesn't have to be just one way to do the privacy loss accounting, right? Or one way to explain the privacy loss accounting. Just like there's a generally accepted set of financial accounting standards, but multiple ways of implementing them, there can be multiple ways of doing the privacy loss accounting and explaining it to technical and non-technical audiences. We need tools for automating this, and that means tools for how to take a data publication plan, an analysis plan, and translate that description into the required differentially private measurements, or noisy measurements, as we've been calling them at the Census Bureau. Associated with each measurement or each workload measurement, there have to be accuracy targets. And in general, we've found there are generally multiple accuracy targets. And so that capability ought to be a part of an automated tool. And then privacy loss budget management, ways to help the user manage the global budget and its allocation across the workload. And then tools for teaching this to a novice user community. What privacy loss management means. I mean, privacy loss management has many direct analogies to sample management in surveys. Instead of a dollar cost, you're allocating a privacy loss cost, right? But there are ways in which skilled survey managers or data users, data designers, can take their knowledge of how you improve the accuracy of one portion of the sample at the expense of other portions of the sample because you've got a finite field budget. Those analogies directly work in privacy loss management, and if the tools could make them more transparent, that would be a big help in my view. The tools should allow you to compare alternative privacy loss accounting frameworks. Different frameworks, zero concentrated differential privacy, other forms of concentrated differential privacy, pure or zero epsilon differential privacy, epsilon delta differential privacy. Those frameworks should be selectable. If it is the case that there's a dominant framework, either by proof for this problem or by inspection for a given set of feasible frameworks, then the user should be able to discover that, or you should help the user discover that. Finally, alternative specifications for the accuracy targets, confidence intervals, root mean squared error, interior cells versus margins. These all matter, especially that last one, interior cells versus margins, which we might have some questions about later. I'd also like to encourage you to focus on big data applications. The future of measurement in government agencies, both statistical and administrative, is in the use of large, natively digital administrative and observational databases. The era where we go to Congress and ask for a multi-million-dollar annual budget every year to do a purpose-built survey is over. I don't think that's a secret to anyone in this community, but if it is, you may quote me because you probably will. These are not as large or as fluid as tech industry data streams. They're what I think Bob Groves coined the term found data, observational data. They have lots of different names. For a long time, they've been referred to as administrative data, but that doesn't have a well-defined schema either. But the reason they're not as large and as fluid as tech industry data streams is they're not generated by multiple interactions with a cell phone over the course of minutes. They are generated by the process of enforcing most of the laws that the federal and state governments in the United States have put in place. Good examples include tax records, pollution measures, Social Security, Medicare, Medicaid records, state and municipal administrative data. Those are the fodder that will increasingly feed statistical and administrative statistical uses. They're the fodder that the Evidence Act anticipated and attempted to enable. There are virtually no tools for privacy loss accounting that stewards of these data can use, especially for data that are shared across multiple agencies. As a consequence, there are two common outcomes: massive suppression or publication without sufficient protection, basically poor confidentiality protection. These impede science, especially suppression, and they endanger public trust, sloppy or insufficient protection. So I've given you a pretty good wish list, and I think I left some time for questions. So I want to just get to one thing I want to kind of call out explicitly. Formal privacy for sample surveys is a much harder problem than the current toolkits are up to. The entire lifecycle workflow from sample surveys, especially the flagship products of statistical agencies, the Economic Census and the American Community Survey at the Census Bureau, that workflow is the product of decades of refinement and evolution. It's essentially impossible to simply add privacy loss accounting directly to these workflows. It does not work. So you have to re-engineer the entire survey lifecycle workflow. And when you do that, you're balancing multiple sources of uncertainty, including the confidentiality protection. But that's the only feasible solution. And so the implementation is necessarily going to be piecemeal as different parts of these lifecycle workflows are re-engineered and tested solutions are engineered into the production code. That is very likely to take at least a decade to fully implement. And I think the OpenDP community should be realistic about that. I know I've had to be very realistic about that. So that's the end of my comments. Thank you very much for your attention. And I saved maybe not a healthy portion of time, but at least some time for questions. Thanks again. I haven't been monitoring the chat, so.
Yeah. I see thank you, John, very much. This is a very, very interesting topic, and then a wide range of things you just covered. I see one question in the chat from Jing Shuo Dong. It says the confidentiality violation null hypothesis formalism is asymmetric, but often neighboring relation to in DP is symmetric. Is this difference important?
Thanks for that question. I deliberately didn't want to make this a mathematical talk. So I'm going to just draw your attention to the variety of papers that have been published on this already. Since it's a point, you can flip which is the null and which is the alternative without affecting the mathematics here. What matters is your definition of what's a neighbor, and then the fact that the universe over which the guarantees are applied is to all databases and all neighbor databases. And so once you either consider the null and the alternative or you flip them, you're going to have essentially the same comparisons. And there's a number of extremely talented experts sitting in this community who can take that question far better than I can, but I think I gave the right answer. My doctoral examination will be graded in private.
Okay, anybody from the co-host group want to chime in on this one? I don't see any other questions in the chat, but if any of you in the audience, you have a question or have a comment, feel free to type in the chat or just raise your hand and then we can unmute you. You can ask it directly.
John, while Annie is collecting questions, maybe I could just add one more. As a political scientist, I wonder if you could comment on the difficult political problems of convincing all of your all of the constituents and the people internal and external and everybody else to make this movement.
So I'll start with the remark that I should have been given and been willing to take communications training much earlier in the process. I now have done quite a bit of that, and the heavy guns that have won multiple prizes for their communication strategy for the 2020 census have been my instructors. So it takes a lot of communication expertise and a lot of technical expertise to be able to understand the question and then address it. I will say that we invested an enormous amount of time in hundreds of stakeholder meetings using trained specialists from the Census Bureau to work with them. We worked directly with the voting section in the Department of Justice, and we worked directly with the principal American Indian Alaska Native stakeholders and with voting civil rights groups and with politically nonpartisan redistricting groups through the offices of the Census Bureau. There was no question that we left unanswered, and the very extensive public debate on the subject highlights a strength of differential privacy, which is that you can have this discussion without compromising anything, but it also shows you one of the big points in the economics of privacy protection. In the end, you've taken many groups to a marginal point. They're completely happy was never going to be achievable. How much they think they could be made happier by a marginal adjustment in one direction or the other is extremely difficult to quantify, extraordinarily heterogeneous. And in the end, the statute leaves the data stewardship decisions to the group designated by the director of the Census Bureau, and that is the Data Stewardship Executive Policy Committee. And it is they and not I who made those policy decisions that Gary referred to in my introduction. And they who have stood by them consistently through the implementation program, and they who deserve the credit for having the courage to do that. Salil has his hand up, although he took it down, so perhaps I got his question, my long-winded answer to Gary. Apparently I did.
Great, thank you. And I see a couple more questions. Scott Moore asked, when you mentioned the lack of tools for agencies to manage privacy budgets for big data applications that require data sharing, do you see this as a problem of lacking tools for applying formal privacy techniques or lacking tools for collaboratively managing the budget itself, or both?
Or both.
Do you see any particularly promising approaches on the horizon?
I believe you are going to get a talk, or have gotten a talk, from Jerome Miklau on the way that Tumult managed this for the collaboration between the Department of Education and the Internal Revenue Service on the education report card. And so I urge you to learn from that example. I'm not citing any census examples because they're not in the public domain yet, but there are also some from work that Tumult has done for the Census Bureau.
The next question came from Mark Antoine Paré. Could you comment further on the progress for real-world explanations of the privacy parameter, which is epsilon, or approaches seem promising? For example, mapping to financial cost, threat models, something else?
So we've spent the better part of it. Yes, I will. Thank you for that question. We've spent the better part of a decade and a half discussing privacy loss accounting in terms of epsilon, but I think there's an emerging consensus in the scientific community, the DP community, that there may be better frameworks for doing the privacy loss accounting. In particular, additive frameworks are the ones that seem to work best, because the idea that so just like in regular budgeting and regular financial accounting, additive aggregation of the primitives to get to the total budget is an essential teaching tool. And as economists have learned from many decades of trying to teach subadditivity, it's really a concept that you only succeed in teaching at the PhD level in the courses in theory. And then the separating hyperplane is something that is largely applied in theory exercises. So additive accounting frameworks, I think, are very important. And that's why we did the final privacy loss accounting framework for the 2020 census using zero concentrated differential privacy and additive accounting using the row framework, which the primitive is harder to explain, which is why translating it to epsilon delta equivalence helps explain it, and why I'm making a plea for better educational tools. But I do think that if we're going to succeed, that teaching additive principles first, the same way I teach budget constraints when I teach introductory microeconomics, is going to have to come before teaching mathematically more complex concepts like the advanced composition theorems that translate the additive tools into epsilon delta equivalence.
Thank you, John. We're a little over time, but let me see if I can squeeze in a couple more questions. So the next one comes from Mona Chitness. Like John mentioned, education tends to be a challenge. On the lines of government organizations and more recent events, is the CDC data possible to get under the fold of DP?
I think there are some, thank you for that question. I think there are some groups that have worked hard on trying to show the ways in which HIPAA can be made to fall under the umbrella of formal privacy. And I would defer to their work. I think that Alexandra Wood is in the group here. Yes, I see her avatar. So that question might be better posed to her. You know, I feel like I'm in a very difficult situation urging another government agency to go all in on formal privacy with the current toolkit and not offering resources to support that. I can't deploy the team that implemented it for the 2020 census because they're not done off to another agency or even to another project within the Census Bureau. So, you know, you're helping enormously by making these tools more broadly available and by developing dissemination materials. That's not just education, that can encourage agencies like the CDC to make use of them.
Thank you, John. One last question before we take a short break. It comes from Jillian Robb. Could you comment on tools for the assessment of any lack of utility that may be the result of making results epsilon DP?
Well, I think I did. Thank you for that question. My comms training is starting to wear off here. I gotta bring it back to the top. Thank you for that question. It is one that has gotten a lot of attention. So, and Gary alluded to some of the things that I think we need to think about. So first of all, if you translate the error associated with the confidentiality protections in the 2020 census redistricting data product into more commonly understood terms like confidence intervals or margins of error in the sampling theory way, the context that you need is the total uncertainty from a full enumeration census, so that the magnitude of those uncertainties can be compared one to the other. And we don't have that tool available for the 2020 census at the moment. We have components of it available for the 2010 census, and one of those components was net undercoverage. And so the error associated with the differentially private redistricting data for the populations of one of the counties that we have a direct measurement of the net undercount error on, counties, is trivial in comparison. The error in counties, differential net undercount error in counties, is in the fractions of 1%. That's the direct number of people who were put in the wrong county in the 2010 census, the estimate from the coverage and evaluation survey from 2010, coverage measurement survey from 2010. So that's one important quantifier. At the block level, it's larger. It's on the same order of magnitude as the error associated with getting the person in the wrong block in the 2010 census, and that's probably appropriate. That the confidentiality protection is a much more important concern at the block level than it is at the county level for most counties. There are some small population counties where that's not true, but for the most part, that's true. So that's the best I can do. We are planning to release what's called a total uncertainty analysis for the 2020 census. It's been contracted for and it's in development. It's a part of the authorized census experiments and evaluations for 2020. At that time, we'll have good quantitative measures that are on the same scale that allow comparison, and that'll include the differential privacy component.
Okay, we are really over time now. I still want to give people a few minutes before the next session. Thank you, John, very much for the excellent talk on the census. And thank you for answering all the questions from audience. I'm sure more questions will come up later on, and then I will direct those questions, to you later on.
Thank you very much. Thanks, everyone. It's been a real pleasure. I enjoyed it.
And now we'll come back at 12 o'clock.